Ever tried explaining something to a computer?
Oh, I know what you mean.
It's like sometimes you just hit a wall,
Yeah.
like talking to a brick wall.
Yeah.
But today we're diving into a paper that's tackling that exact problem.
Okay.
How to make AI think more logically.
Interesting.
We're talking faithful logical reasoning via symbolic chain of thought.
Hmm.
It might sound kind of jargony,
Right.
but it's really about bridging that gap between how our human brains figure things out
Okay.
and how AI processes information.
Yeah, we're talking about bridging that gap between how we reason
Exactly.
and how computers need that structured information.
Yes. We use common sense. We read between the lines.
Right.
We can kind of like, even with missing information, we can usually figure things out.
Exactly. Exactly.
AI, traditionally, it needs everything spelled out,
Yeah, like step by step.
like it's following a recipe.
Precisely. And this paper really highlights how that can actually be a problem. They give this example with an external solver called Prover9. And sometimes Prover9 would actually fail because crucial details would get lost in translation from, natural language, how we speak,
Right.
to that more formal logic that it understands.
So it's like you're giving someone a recipe, but like some of the ingredients are missing.
Exactly.
No matter how good of a baker you are, you're not going to end up with a cake.
You're not going to get that cake.
That's where this chain of thought idea comes in,
Yes.
right? Like giving the AI a more detailed roadmap.
Yeah, you're on the right track, chain of thought or COT prompting. It's all about encouraging the AI to think step by step.
Okay.
But even with COT, like the paper points out, AI can still stumble with more complex logic.
Right.
Like sometimes it can fall into those common logical fallacies
Okay.
that even we as humans sometimes trip over too.
Right. Okay, so you're probably familiar with COT prompting.
Yeah.
But what's really cool here is how SymCot takes it to the next level. By integrating symbolic logic, those clear mathematical symbols and rules, with that flexibility of language models.
It's like this, the symbols provide that structure, like the scaffolding for the reasoning,
Okay.
while the language model fills in those gaps and interprets the nuances of the problem.
Okay. I'm starting to see how this SymCot thing works.
Yeah.
It's not just symbols or our words.
It's both.
It's using both in a really smart way.
Yeah, it's this really elegant kind of hybrid approach.
But how does this all work in practice?
Oh,
Is there like a step-by-step process?
there is.
Okay.
SymCot uses 4 main modules.
Okay.
And what's really fascinating is that each one is powered by a large language model.
Oh, wow.
So first, you have the translator, which takes that problem presented in our natural language and converts it into those symbolic expressions that, the AI can really work with. It translates the problem into a language the AI can really sink its teeth into.
Gotcha. So it's like translating English to like computer code?
You got it. Then we've got the planner. This module takes that complex problem
Okay.
and breaks it down into smaller, more manageable chunks.
Makes sense.
Kind of like outlining an essay before you dive into writing.
Right.
It's creating that step-by-step plan to reach a solution.
Very methodical.
Exactly. Then comes the part where the magic happens. The solver.
Okay.
It does exactly what it sounds like.
It solves.
It solves. Using that plan we just talked about and those symbolic representations,
Okay.
applies strict logic rules, no fuzzy human thinking here,
Gotcha.
works through those steps.
Okay, so we've got the translation, the plan, the solution. Time to
Wow.
celebrate, Ro.
Hold on, we're not done yet.
Oh.
We've got one more super important module, the verifier.
Oh, okay.
This one double checks everything, makes sure we're on the right track.
So it's like having a logic teacher looking over your shoulder.
Exactly. It makes sure that initial translation into symbolic logic was accurate. And, get this, it checks each step the solver takes to make sure every logical move follows the rules.
No cheating.
No cheating! This is serious logic we're talking about.
This SymCot is sounding more impressive by the minute.
Oh.
But did they actually test it out, like, in the real world?
They put it through its paces, believe me.
Okay.
5 different data sets, including one based on, get this, the logic games you see on the LSAT exam.
Whoa, the LSAT. That's intense.
Yeah, they weren't messing around.
So what kind of logic problems are we talking about here?
So they tested it on 2 main types.
Okay.
First-order logic. Think those classic logic puzzles like all cats are mammals.
Right. Very structured.
Exactly, pure logic.
Okay.
And then they also tested it on constraint optimization.
Okay, what is that?
It's about finding the best solution within a set of limitations. Think of it like planning your week.
Okay.
You've got your appointments, deadlines, errands, but you got to find the best schedule.
Oh, that's a constraint optimization problem every week for me.
Exactly. It's finding that sweet spot, the best solution given what you have to work with.
So they really threw everything at SimCot. Did it pass the LS?
Well, it didn't actually sit for the exam,
Right.
but it consistently outperformed other methods,
Wow, that's really impressive.
especially on those complex reasoning tasks.
Okay.
Remember the whole baking a cake without all the ingredients problem we talked about?
Yeah, with the solvers.
SimCot, much more resilient to those translation errors.
No kidding.
It's almost like it understands the context better.
Hmm.
Fills in the blanks, if you will.
Wow, that's pretty amazing.
It is. It means SimCot could be way more reliable in these messy, real-world situations.
Where you don't always have all the information.
Precisely. Not like those older systems that would fall apart if one thing was out of place.
Right, right.
Right.
So we're talking more than just logic here. It's adaptability, too.
It's the whole package.
Mm.
Robust reasoning, adaptable, and actually gets things done.
Okay, so beyond acing logic puzzles, why does this matter to, like, the average person?
That's the million-dollar question, right? It's not about AI just solving puzzles in a lab. This is about real-world impact.
Okay, give me an example.
Tons of examples. Think about things that need, like, careful, accurate reasoning, things that can really have an impact.
Yeah, okay.
Legal research.
Okay.
Imagine an AI that can go through all those case files, all that legal jargon.
Right, mountains of documents.
Exactly. Not just finding the right documents, but like actually understanding the arguments, finding those precedents, the logic behind the law.
Oh, wow, an AI lawyer. Sign me up.
Right. Think about how helpful that would be.
For sure, especially for someone who doesn't speak legalese.
And that's just one example. Contract analysis, that's another big one. SimCot could make sure all those clauses, those stipulations, actually make logical sense.
Oh, that'd be nice.
No more signing your life away because you missed something in the fine print.
Right, that's always a worry.
Exactly. SimCot can help avoid that. And it's not just legal stuff. Think bigger.
Okay, like what?
Medical diagnoses, we're talking about AI that can look at symptoms, test results, your entire medical history.
Wow.
And use logic, real reasoning, to help doctors make those diagnoses faster and more accurately.
That's incredible. Faster, more accurate diagnoses.
Exactly. Better outcomes for everyone. So we're talking law, medicine, the possibilities really do seem endless.
Yeah, it's exciting to think about. But I have to ask, I mean, isn't there always a chance, even with all this fancy logic, that the AI could still get something wrong? We're talking about some pretty big decisions here, right?
That's a valid concern, absolutely. With any new tech, you got to be cautious, right? But that's where that faithfulness of SimCot comes in. That verifier module, remember, double-checking every step.
Right. No room for error.
Exactly. Reduces the chances of, like, a lucky guess,
Oh, so it's not just about getting the right answer. It's understanding why it's right.
That's it. And that's super important when you're talking about AI making big decisions.
Makes sense because you have to be able to trust the process, especially with things like legal stuff or health.
Exactly. Trust and transparency. That's what makes this so exciting.
So where do we go from here? What's next for SimCot? What's the next step in all of this?
Well, the paper hints at some pretty cool directions. Remember those external solvers we talked about earlier? Each approach has its strengths, right? SimCot with its reasoning, solvers with their raw power. Now imagine combining them.
A logic dream team.
Exactly. Working together, tackling even bigger, more complex problems.
It feels like we're on the verge of something really big here. A whole new era for AI.
I think so too. As these language models keep getting better, who knows what they'll be capable of?
Yeah, it's really amazing to think about. Well, there you have it. We took a deep dive into SimCot, learned how it's changing the game of AI reasoning.
It's really fascinating stuff.
Truly groundbreaking. It combines the power of symbolic logic with these flexible language models.
And this is just the beginning.
It is. It's going to be really exciting to see where it all goes. All right, that's it for today. Until next time, keep those brains engaged, and we'll be back soon with another deep dive.